Hey, hello everyone. Welcome to the session on generative adversarial networks. GANs are one of the most exciting developments in the field of AI with application that spans several domains. So this is a lecture series uh, on GANs where we have also included hands-on examples. So let's see like how is it that we can chain GANs, what do we know about GANs and all those things. Okay, so before going ahead, like with the introduction to GANs, let me quickly introduce myself. I have a background in reinforcement learning and expertise in an extensive experience in AI. If you want to see my like projects and work profile, you can go to this link and see my projects and like what I have worked on. This is a little old, but I think it will actually take you to my Google Scholar page or my LinkedIn page. So I have several publications in top tier conferences and journals in like in AI. Most of these are A-star conferences. I'm currently serving as an AI scientist and manager at EY India, where I primarily work on optimal hedging using reinforcement learning and market surveillance using Gen AI. I also work on several other like aspects here, like in the domain of finance. I'm also serving as a mentor at AI-Shala Technologies Private Limited. I've received travel grant awards from many prestigious organizations, including from Microsoft and Google, to present my work in international conferences. I've also worked on industrial robots, like in Sony AI Lab, Tokyo, where we worked on the control of the kitchen robot. So I have also received several performance-based awards for my work, and rest is detail. So we also have a very large AI community in India. So if you are interested, you can join the community using this link. So in the community, we have several mentors. First is myself, Anuj, like who is actually working at Lilly and has worked on and several other prestigious organizations. Akshay is actually working at ICER Bhopal currently, but he has a postdoc from University of Buffalo, from New York, and like there are many mentors we have which are working on many prestigious organizations all over the world. So if you are part of that community, you can get a chance to talk to these mentors. So you can join our AI club if you are interested in a career in AI, or if you want to see like what is happening in the field of AI. So you can go to this channel. Students are actually doing great in our community. So Saksham from MSIT received like secured All India rank of 11 in GATE 2024. Amulya from MIT Manipal secured research associate position at IIT Delhi. Many students published papers in top tier conferences and so on. So in this lecture series, we will be actually talking about a few uh, like recent developments in the field of AI, like which is like all of these will be based on GANs. We'll first start with the introduction and applications of GANs in this first lecture, that means today, and then like we'll talk about how the GANs evolved, how to train the GANs, what are the challenges in training GANs. And then we will be talking about like three most popular GANs. One is the deep convolution GAN, DC GAN, from where the field of GANs actually, or the field of generative AI actually evolved a lot. And then we'll also be talking about conditional GANs, primarily we'll be talking about pixel to pixel GAN and cycle GAN for paired image to image translation and unpaired image to image translation. And then we will finish with unseen image translation. We'll be also having some coding examples. We'll start the coding examples like in the second session, fourth session, fifth session, and sixth session. Okay. So be with me. If you guys have any queries, you can comment and we'll try to uh, answer your queries. Okay, so in this lecture, we'll be talking about history and evolution of AI, and we'll also be talking about the introduction of GANs and the application of GANs. Okay, so GANs are one of the most exciting developments in AI, with applications that span from creating photorealistic images to generating musics, even assisting in medical imaging. Today, let's just explore the foundation of GANs, their evolution, and how they are trained. Okay, so basically, uh, let's just see, like how is it that the GANs have actually uh, be used in the field of computer vision. Okay, so like before starting with the actual stuff, AI is everywhere in our lives, from autonomous vehicles to applications in healthcare. The AI landscape is evolving rapidly, and generative models like GANs are pushing the boundaries of what machines can create, allowing us to move beyond the traditional AI applications. And we are in the era of AI agents, which is transforming industries, automating tasks, and enhancing decision making across domains. Before we start with the actual generative AI stuff, let's just see one of the most important, or maybe you can say one of the initial model of the generative AI domain, like from which we started seeing the revolution. Generative AI was actually existing way beyond as well. So basically in the early 2000, so there were many generative models were used, but now I think this field actually evolved starting from GANs. So let's just see what is it that we can learn. Before moving ahead, I just want to show you some efficacy of the generative models. This is not related to GANs, but let's say if I am giving a query, like based on the pose of the image example one.jpg. So this is example one.jpg. The pose of the boy is actually one hand up. And the description of example two, this is example two.jpg. The description is that a boy is riding a bicycle. Okay, please generate a new one. So we are only giving two images as the input and one query. Okay, so we want to do something. So let's say if we give this particular thing as an input to the LLM, so there are several models which are actually being proposed to do image generation. So this is the image totally generated by the LLM by only getting this query as the input and the two images. Okay, so here you can see the boy is riding a cycle with one hand up. Okay, so that means this is actually matching the description very correctly, and the all the imagination or all the thinking was done by the computer itself or the LLM itself. Okay, so there is a lot of benefit that the field of generative AI is actually giving. So this is actually done by task planning in LLMs. We'll talk about this when we will be talking about LLMs. But I just wanted to show you that this is the magnificence of generative AI, and this is the right time when you should start with the generative AI. Okay, so let's just see like what is it that we can actually learn from today's session. Okay, so the first thing is why generative models. Unlike discriminative models that classify and uh, predict, generative models can actually create the new data. Okay, so here we only predict the probability of y given some data x. The key limitations of these are that they only know about the probabilities, but they cannot sample from the actual probability distribution. They are unable to generate the new images. They don't understand about the data and so on, right? So they only know about this probability, right? What is the probability of y given some data x? Okay, so this ability to basically generative models are actually capable of generating realistic data similar to the training data. So the data is actually known to be uh, high in quality and diversity. So this ability to generate realistic data allows us to enhance data sets, explore creativity, and handle complex tasks in areas like data augmentation, synthetic image generation, and so on. Okay, so let's just see about this field. Before we go ahead, let's just see a brief history of AI with deep learning, how the things have actually started. This slide actually represents a high-level timeline of key milestone in the evolution of AI and deep learning. starting from the early concepts of artificial neurons to the modern era of advanced AI models. We can see how each milestone has laid the foundation of the current landscape of artificial intelligence. In the early days, we had the artificial neuron. So basically, here, which was introduced by McCulloch and Pitts in 1943. This was one of the first mathematical models of a neuron, which laid the groundwork for later neural network research. Moving into the 1960s, if we see here, we encountered a big roadblock with the ZOR problem. So, XOR problem, you can say, in 1969, where the Minsky and Peppert actually highlighted that the perceptron model cannot even okay, sorry, in 1969, the perceptron model cannot even solve the zone problem. So this was the first dark age uh, uh, of neural networks. It actually didn't demonstrated that single layer perceptron could not solve the non-linear functions, leading to a decline in the neural network research, a period we call the first dark age of AI. A significant breakthrough actually came in to 2014 with the introduction to GANs. But before that, so basically after this dark age, Jeffrey Hinton's group actually proposed backpropagation, where we could actually introduce non-linearity in the perceptron model by training the multiple perceptrons in one model on one network, we can say. This was the second golden age where every paper in the conferences were actually based on neural networks. And then SVMs came into picture in 1995. These neural networks were highly complex. If you have a very large network size, they can't be trained on the single computer. But SVMs were very effective. They are very lightweight, and so due to the performance of SVMs, the second dark age of the neural networks actually came. But things have actually changed when AlexNet came in 2012 for object recognition. So where all the all the models that were based on SVMs were actually beaten by the LXNet, and so deep learning based models actually showed that they are way accurate than SVMs. Okay, so then SVMs stopped to come into existence, and then in 2014, Ian Goodfellow actually proposed GANs. From this, you can say that the real revolution in the field of generative AI actually came. In 2017, the transformer model was introduced by Vaswani and his team from Google, and it actually laid the foundation for models like GPT, and they enabled highly effective sequence processing without the limitations of uh, just a second, without the limitations of just a second of recurrent neural networks. So these actually you can say that, look, whatever models you are seeing or the LLMs you are seeing, like these because of these two uh, you can say milestones, like in 2014 GANs were proposed, and then 2017 transformers were proposed. We'll also see that like how GANs and transformers can be linked with each other, because I think, to my belief, GANs were the foundational models from which researchers actually start thinking of transformers. Okay, so because it was actually doing a lot of things that the transformers are actually doing without convolution layers, or maybe they are like kind of like a great extension to the recurrent neural networks. Okay. So okay, next slide. Okay, so now we'll talk about GANs in this particular lecture. We'll only be talking about the introduction, and we'll only be talking about their applications. Let's say if we define GANs, GANs are the type of generative models that consist of two neural networks, the generator and the discriminator. The generator tries to create the realistic data, while the discriminator uh, aims to differentiate real data from the generated data. This competition drives the generator to improve, producing increasingly realistic outputs over time. Okay, we'll see like how these are actually produced. So before we go ahead, let's just see some applications. So GANs have a wide range of applications. They are used for image synthesis, image translation, even for video generation. GANs have significantly impacted industries by providing high quality synthetic data and enabling creative applications. Okay, so these are the applications that I think like you I'm not sure like how many of you actually know GANs, but these are the applications which GANs have actually shown a great performance. One example, if you see for image to image translation, for example, let's say we have an input image of a horse, and then using GANs we produce this zebra image where like the same actions that were done by the horse are now done by the zebra. The only thing that that is changed here is that this horse has actually changed to the zebra, keeping all the other environment intact, right? So this is the efficacy of GANs. We'll see how this thing is actually done. I think in the third or fourth lecture, we'll see how the image to image translation is done. Okay, so a popular application of GANs is super resolution, uh, where we generate high resolution images from low resolution input. SRGAN is one of the that model, which is specifically designed for this purpose, and it finds applications in the fields like satellite imagery and medical imaging, where resolution matters. Right. So if you use specs, you can actually compare by resolution is very important. Just remove your specs and then put on your specs, right? This actually gives you a feeling that how important this particular application is. Let's say we have given this particular image as the input. So this is what srgan actually generates. So let's just see uh, how high quality the image is, and this is the original ground truth image, right? Just see, right? All the information is actually retrieved very accurately by srgan. Another good model of GANs is iGAN, which is in short a short form of interactive GAN, which allow users to interactively edit and visualize images in real time, showcasing the power of GANs for creative manipulation. So, for example, let's say when the user actually puts a green line at the bottom of the image, then the GAN actually produces images of the grass. If this kind of structure is actually made, then this is what the GAN actually generates. So you can actually interact with the GANs, and like this is the kind of like image that the GANs can generate. Just see high like good information the GANs are actually producing. Okay, so another potential application is text to image synthesis, which uses GANs to generate realistic images based on textual description, bridging language and vision in AI. So I believe that this is the efficacy that GANs actually showed by only having some description. For example, this small bird has a pink breast and crow and black primers and secondaries. Okay, so this is what it actually generated from the discriminator. Sorry, from the description. So basically, like you give a description as the input, and then there are convolution layers which are actually based on this description. They are actually generating an image. Okay, so the generator model is a convolution layers, and the discriminator is actually based on the deconvolution layers. I think deconvolution is a very loose term. We'll say like what is it that we actually call the this uh, as the actual layer, like when we will be talking about the DC gap. Okay, so this is like I believe that this particular idea also gave birth to LLMs, where like we actually give only one textual description, and then it actually generates like a image in the vision transformers. Okay, another is shape modeling using 3D GANs. GANs and shape modeling enable the generation of complex 3D shapes, aiding fields like computer graphics and virtual reality. Okay, so like the images can be generated in the 3D fashion as well. Just see, right, how the like images are generated by the GANs. Okay, image translation with GANs is also is very popular. Uh, so basically, it transforms images from one domain to another. For example, day to night, night to day, which demonstrates versatility in style transfer and adaptation. So GANs are very popular in this. So for example, let's say if you give this particular like image, it actually generates a multi-story building. Okay, and from black and white to color, and from edges to photos, from day to night, from alien image to the map image, from the segmentation mask to the original image, right? So this is like very popular in industry. Basically, at least we the computer vision scientists actually use this. So for example, let's say you have segmented mask, can you generate the various forms of the image that are possible, right? So this is one of the important image to generate the simulated data sets as well, augmented data sets. Okay. So we'll see how these things are actually done. Okay, so you can go to this particular link, philippi.github.io pix2pix. Basically, the pix2pix provides an interactive demo. Where you can actually upload a sketch image, and then it will actually generate the image for you. Go try it; it's fun. Another very important GAN model is the cycle GAN, where we do unpaired image to image translation. So, for example, like we have paired image to image translation. I think the last image, like pixel to pixel, is actually paired image to image translation we do. So where what let's say we have sketches and we have the corresponding the paired image, which like actually gives the distribution of the data that this image corresponds to, right? So, for example, sketches and the actual images are corresponding to each other. But let's say we have unpaired images. We have the images in one domain, images in another domain. We don't know which one associates with which one, right? Which image in the domain X corresponds to which image in the domain Y, we don't know. So this is unpaired image to image translation. How is it that we can transform one image from the domain X to another image in the domain Y? So this is another example for which we use cycle GAN. We'll see how this can be done. This was proposed by Hardik. You can go to this particular page to actually see about the details. Cycle GAN is actually very popular for unpaid image to image translation. There are so many examples available. So, for example, in their paper, they actually showed that like various unpaid image to image translation can be actually done. So, for example, zebras to horses or horses to zebras. Uh, uh, Summers to winter, winters to summer, and then maybe let's say we have a, photograph style, it can be transformed to different other styles. Okay, so for example, Monet to photos, photos to Monet, right? So these are the styles that can be actually transformed. Okay, so these were a few applications of GANs. I think in today's session we'll be only talking about that. So thank you for the today's session. Tomorrow we will be actually talking about the evolution and training of GANs, where we will be talking about more technical details. Uh, and So what I would suggest is please subscribe to the channel so that you can actually get the notification for all the lectures that we will be having. One more thing, if you are interested in our community, you can join the community using this particular QR code. Okay. Thank you for attending the session. See you in the next lecture.